Yeah. I'm not sure if it will record speaking though. Only the sound that comes through. Oh, we'll see how it goes. Yeah, all right.
Yeah, if you chuck it on YouTube, that should be fine with this size. Although I guess, yeah, it might chew up your data if you got limited data to upload it.
Oh, I have unlimited. Yeah, anyway, it doesn't matter.
Oh, sweet.
Yeah, so this was the other mesh I made, or one of the other ones I'm showing. Yeah, so this is Pripyat in Ukraine. And again, just like from drone imagery that I found on the internet on YouTube. And again, like, you get some pretty good, reasonably good meshes actually out of it, considering it is like a screen recording and with no EXIF data in that imagery. Again, it's kind of like a bit lower quality because of the upload to ArcGIS Online. But I have the original I can show you anyway, later maybe.
So what's the format of that file like? So ArcGIS can handle these 3D models?
They can, but they need to take like a tiled version of it. And then as well, the texture suffers as well. So I think it compresses, like it would maybe compress the texture. So I usually like to use TIFFs or JPEGs, no, TIFFs or PNGs, because you don't really lose any data. And then they must convert to like a JPEG or something, and then it compresses the texture. So that's why the texture does look, this here is actually from the model itself, and you can see the writing on top of the buildings. And then that ArcGIS scene, you could not make it out well. Yeah, it's just the, I think ArcGIS those kind of models yet. This is the next one.
It's a mesh, right? Sorry to interrupt. Are you going to tell us more about what is it like computer games use polygons, right? They make a wireframe basically and lay a texture over the top. Is that what's going on? Or?
Yeah, it's a triangulated mesh. I can run through it later, like when we get to that part. But basically, yeah, it's a triangulated mesh on tie points from the imagery, or key points in the imagery. So it looks for, like, when we have overlapping imagery, you'll generate key points. So that's like a feature that can be seen in one image and in other images. And they're the tie points. And then basically each tie point is like basically a point in 3D space. And the triangulated mesh is generated from those points. But that's, yeah, we can run through that after, like that's later. When we run through that process, I can run through. I'm just doing a bit of a show and tell at the moment of the stuff that I've created. And this is something that I've never done before as well. Is this one here is photogrammetry using equal rectangular images. So that's a 360 images you get on Google Street View. So this church in Spain, I just used downloaded these Google Map images. So these 360 spherical images. Typically, these aren't good for photogrammetry, but I wanted to see how they went. And Agisoft Pro Edition does have a ability to process 360 images. So just downloading these images from each of these points here. So I basically just extracted these from Google Maps. And then I can show you the mesh that was produced from these images. And I've just uploaded them to my Sketchfab account. I think, Will, you've seen this one as well, haven't you? So this one's like, yeah, 3D again, 3D model.
Yeah, right.
This one I'm actually really.
Did you download it? Right. You downloaded each spherical image from Google Maps?
Yep. I'll show you my method that I done with it. Yeah, I can show you how I did that now. So I use this this iStreet View. So someone made a API or a program that can extract or request to the Google API these images. So I provided a link here. So basically, you have your Street View open, oops, you get your Street View open. You take this code here. So in the web address here, there's a code. I think it's in here somewhere, and that's the image ID number, and we need that to extract that from Google Maps. So basically, we just put the web address in here. So this is this iStreet View. It's a web address you just put in the browser. So you load the panorama with that link, and this image ID here, which is in the URL, you copy that, and then there's another program that I had downloaded. There's a pro version and there's a free version, so I just downloaded the free version. But again, this is someone that someone made. And then you just put the panorama ID in here, and then you just put a location to save, so you could save it on your desktop or wherever. And then you just download the panorama, the resolution size that you want, and download. So the pro version, you can actually just like draw a polygon over a map, and it will extract every single 360 image in that area. I'm not sure how the program is made, but basically I tried looking up on the Google developer page, and there is ways that you can like make requests to the Google API, and you can extract, say, for example, you could extract this image here at a certain extent and a certain angle, or you could extract the whole 360 image. I hadn't really got that far yet as to how to, if I wanted to make my own program to extract these images myself. But for the moment, I just use this method to extract the 360 images using the Street View download 360 and the iStreet View website. Yeah, does that make sense?
You basically have to hack it all together. It's great.
Yeah, and it took maybe just Googling and just just trying things, and then I just sort of discovered it. But yeah, that's how I've done it. I've tried to actually do it for a few other things. The problem with using the 360 imagery is the overlap. So there's actually quite a few meters between each image. So it works in here, like the ceiling you can get, because basically you can see the ceiling from nearly every point in here. You see that you can look up, you can see every point. But traditionally, like any Street View, the distance between each photo is too great. So there isn't very much overlap. So that makes it very difficult to use. I think only really in these indoor areas you can use it for the moment, but I haven't yet really explored much further than that. So yeah, the next thing I was I started playing around with is like photogrammetry using a smartphone. And yeah, smartphones are good because they're like affordable. Everyone has them, so it's really accessibility. And smartphones have gotten to a point where they can be used. Well, they're good enough to be used for photogrammetry. So yeah, basically, today this is what I was making today. So I did a 3D scan of all my rooms in the house, like quick one. So nothing too detailed, but this was about 1,000 photos. This whole model here. Up until today, I've never actually successfully done a full scan around the whole house. And I can show you this is the first one that I made a long time ago, the first model I made of my house. And I never managed to successfully merge in this corner here to get a full model around. And I think that has the thing that maybe prevented that is the sunlight and the contrast. So this is areas in shadow, and this part is usually in sunlight. So when you turn around this corner here, these parts here don't usually line up, or the key points aren't identified by the software because of that change in contrast when you turn in that corner here. So there's something that we'll talk about in a sec, how maybe this was successful today and not previously. So this is basically my phone that I use. So yeah, I just have a Moto G9 Play. It has a 48 megapixel sensor. So there is some pixel binning that goes on. So it combines basically 4 pixels together, and then you get a 12 megapixel image at the end. So most smartphones have a fixed aperture. So mine's a f1.7. They can maybe be like, iPhones might be a little bit different, but generally they're fixed. Maybe some of the new phones, they have a slight variation. So maybe it can go like f.17 to 2 point something. All these settings here, so shutter speed, ISO, sensitivity, and white balance, color temperatures are pretty standard, but yeah, they can be changed. Focal length is quite short, so 4.71, but I think this focal length is maybe has an equivalent to like a standard camera. So on the specs, it has a 27 millimeter equivalent. So if this phone was an equivalent DLSR, that would be what the focal length would be. But again, I'm not sure something you can compare with a DLSR because they're basically a different product or different thing basically. So yeah, HDR features. It can shoot video in 1080p, or basically it's about 2.1 megapixel, and at 30 or 60 frames per second. And this phone that I have is $300, so it's quite affordable to anyone. So some of the things we might want to ask is like, what settings do we want to use when we're using our phone for photogrammetry? So we could use, do we want to use a JPEG or RAW format? Do we want to use auto or manual mode? Should we shoot with the native 48 megapixels, or should we go for the 12 megapixel image resolution? What white balance values should we leave them fixed? ISO values, do we use HDR or not? And can we shoot with video, or is it better to shoot with still or video? And if we do shoot with video, would we want to use 30 frames or 60 frames per second? So sort of to test this out, like what would be the best settings? I just did a series of tests. So I just did my lounge room, just a one wall, just to run some tests through that. So the 9 tests that I done was basically different modes. So whether it was manual mode, auto mode, auto with HDR enabled, auto with the 48 megapixel resolution, HDR with 48 megapixel, and a series of tests. So the video, I shot 2 lots of video, and I extracted 10 frames. So each test has 10 photos in it. So we have like 10 photos in manual mode in each. And I shot some videos and I extracted 10 frames from the video just to be sort of comparing apples to apples. So the thing that I basically wanted to test, actually before I'd done this test, I already sort of knew what the recommendations were. So the recommendations for photogrammetry is that you shoot your photos in RAW format. It's recommended as well that you have a fixed ISO value as low as possible. So that is like the ISO is a sensitivity to light. So with higher ISO values, you're going to have more noise caused by light. Generally, you should have a fixed white balance fixed white balance setting. Generally, the aperture should be quite small, so you can get a focus in close and far distance objects. But again, like with the smartphones, apertures are fixed at 1.7. And just sort of to get some sort of comparison with like a standard camera, I have it's sort of an older DLSR camera, just a Samsung NX10. And I just reduced the aperture down as low as it could go, 3.5, just to sort of give it some comparison to that. A slightly bigger sensor, so a 40 megapixel image. I think it has a 1-inch sensor, which is quite large. There's something that I should have mentioned before as well, that my smartphone has a 1/2-inch sensor, so that's quite small. But yeah, generally the bigger the sensor, the better. Probably the only thing that really stands out here is the file size at the bottom. So in megabytes, for 10 photos, 229 megabytes for the RAW format. So when you're shooting 1,000 or more photos, shooting in RAW can become, quite large. So that's where I generally, from a drone or for most cameras, they shoot in JPEG. But although the recommendation is the rawest possible. So that's some of the things we might explore is like, some of these settings here, are they beneficial or are they detrimental to the process? Is Will coming? Wilfred's coming. Might just wait for Will to come back.
Hey, sorry. I don't know what happened. Anyway, we're back.
Okay. So the first step is image alignment. So basically that is what's shown here is each point is it's called a tie point. So maybe what I might do is I might just show here. So this is the test that I've done. If we look at an image, tie points, few matches. So if we look at an image, I don't know if we can zoom in here. No, I can't. You can sort of see like here at the top we have one image, and then at the bottom we have another image that is similar. So it's basically matching features in the image to another image. So you can see sort of like the clock here, the numbers on the clock, it has identified them in both images, and each line like drawn across represents a match. So out of this image here, we have I think what does it say, 3,421 matches between these two images, and these matches is basically what is shown here in this image here. So each point is a match between these images here.
Alexei, this is done manually or it's automatic? Like you run through some tool, or you have to match? How you calculate all the points, for the matching of pixels?
I'll just show what I do then. So basically you have your empty workspace. You would add your photos. You just select your photos. You open them up, and then you have your photos down here. You just go in this workflow tab. You just basically follow these steps. So it's quite an easy piece of software to use. You select align photos. So these settings here, so firstly accuracy, so highest basically just means that we are processing the imagery at its full resolution, so its full size. If we picked high setting, it will process the photos at half resolution. And basically what this results in is so the amount of key points that are generated. So when you generate it at half resolution, you're going to get less key points identified in the imagery and so on. So basically it's half resolution, quarter resolution, an eighth resolution. Oh, sorry, no, full, half, quarter, an eighth, and then the 16th resolution. And then some other settings here. So generic pre-selection, basically what that does is the software will run through the imageries quickly at a lower accuracy and start identifying matches among the imagery. So it may speed up the process, but basically by running through the images quickly, you can start to identify what images might match earlier on before running the whole process. Reference pre-selection, basically, if you've run this process before, it can basically use some of the matches previously to help align again. You have some options here for how you want to align images. So source, this one's only available in the Pro edition. And that basically pulls, like, for example, if you were flying a drone, you would have like your GPS, and sometimes in the EXIF information, you would have like orient the rotation, the yaw, and the roll of the vehicle as well from the IMU. So you can use that to help align the images to work out the angle, or basically the position of the camera. Sequential basically will look for matches in a sequential order. So basically the way that I have shot these images. So we have 1, 2. They're basically shot in sequence of each other.
Ah, okay.
That's why you'd use sequential. If they weren't in that order, so maybe they're all over the place, but in my case, I've got them in a sequential order.
Okay.
You might select estimated with generic pre-selection enabled. And that basically will just start identifying pairs in the whole data set without necessarily looking at them in order. The next, in advanced tab, you can have a limit on key points. So generally, I just have this unlimited, but you can get to a point where maybe there's too many key points generated. So I'd say like no more than 100,000. But then it depends on what you're doing and the type of images that you're processing. So when you get over 1 million key points identified in the image, you can really increase the processing time, or the whole processing time. But the recommendation on the Agisoft documentation is 100,000 key points and 40,000 type points as a limit. Exclude stationary type points. That's basically like if you were to have your object on maybe like a turntable or something, and you were just taking photos and your object was rotating, but the background behind was stationary. That's what you'd call a stationary type point, because between each photo, it's going to see that background and it's going to see it as a match, but the matching points aren't moving. They're basically stationary. So you can choose to exclude those points as like a stationary background. And that could also work with things like points that are maybe far away, so perhaps the sky. But typically, it's not always that effective with the sky, because you might have clouds that are moving, which can add noise to your alignment. Guided image matching is pretty much if you're using like really high megapixel images, so like 100+ megapixel. We can probably discuss that later, but I found with the higher megapixel photos, we generated less key points. So this is like, I guess, another algorithm that helps match or detect points. Typically, you only use it if you're using high resolution imagery. And adaptive camera model fitting, what was that one? I can't remember what that one was. I think that one was, oh yeah, sorry. So I think as you're aligning the photos, it does corrections as far as working out distortion in the lenses. I think it does some calculations. This basically allows the software to be more aggressive with how it corrects and calculates. I think what I mean by the calculations is if we go to camera calibrations, there's all these coefficients that get calculated as the alignment process happens. So I think generally it won't adjust. I think it was a B1 or B2. It won't adjust them, but it will adjust everything else. But maybe I think with that setting on, it adjusts everything quite aggressively. And this is like let's say the tangential distortion and like the I can't remember exactly what they all are, but yeah, basically the coefficients mainly like the I think they're related to like the lens distortions and things like that.
Are these settings applied automatically to all of the photos in the workspace there on the top left?
No, so they're only going to be to this chunk here. So these are called chunks. So the workspace is the whole thing. Each one is a chunk, so it's its own separate thing. Hang on, it's just loading a bit. Yeah, so each one you have to do, you can align all of them in one chunk if you wanted to, but I did them all separate because I'm basically doing them as separate tests. So yeah, each one's its own thing. You do an alignment on each chunk. And basically, you just create a new chunk, and this is an empty workspace. So then you would add your photos. You might add those photos, for example. In they go. Run your alignment process. Select the quality you want. So I typically always just go the full image resolution unless I have like 1,000+ photos. So like a large, like say a large project, I might start on the lowest and just see how it goes. I'll go sequential because I shot them in an order. Because I'm doing on a lower setting, I just leave everything 0. Exclude stationary tie points. We don't have any of those anyway, but I usually just have that on as default.
Are these geotag pictures or simple pictures?
Was that sorry?
Geotag pictures or like plain pictures, like
It can take it can take any picture. If it has EXIF data, that helps with it. But you can just take normal pictures as well. So it's not really, doesn't really matter.
okay.
So if you have like pictures with a lot of EXIF data, it'll show up here. So when you right click your image, it will have all the information here. So if you have like, you know, longitude, latitude information, it will be in here. If you do have that, there will be basically before you run the alignment, it will know where that image was taken, like roughly from just the longitude, latitude.
Yes.
I can actually show you, or maybe I'll show you later. But yeah, if you have drone imagery and if you import drone imagery, it will have you know, that information in there, and it will basically have a point where the image was taken roughly. But yeah, if I had turned location on my phone as well, it would have a longitude, latitude. But I purposely leave the location off because the longitude, latitude, or the location data from the phone just adds error to it, because there's like 5 to 20 meter error in that position. So there's no benefit in having it. So I purposely leave that out.
Okay.
Yeah. Okay, so when you run the alignment test, when you run the alignment, hang on. So I ran the alignment for each set of photos. So you know, the manual JPEG, the manual RAW, all these ones, different tests. The main thing is like how many tie points are generated from those 10 photos. So you can see the photos that were shot in RAW format generated the most tie points, 27,000. And the one that shot the least was the video shot at 60 frames per second. And surprisingly, the high resolution imagery, the 48 megapixel images, also generated very little tie points. And you can see here, so we have the manual RAW. I'll just click that. We select tie points. So you can sort of see an idea how dense it is. And if we went to, say, the 60 frames per second video, yeah, it's not as many. But it's actually probably hard to tell, actually. But yeah, there's not as many.
So all of those little dots on the screen, is that just indicating a poor model because there's very few tie points?
It's not actually a model yet. So these points are just, they're basically just matches in the imagery. So I don't know if you saw this before.
Between photos that it's automatically extracted.
Yeah, so these here. So
okay,
each line corresponds to a match from
a point on the screen.
Yeah, and then each of those matches is a point on the screen. So ideally, you want more matches, you have more points. So having a thinner point cloud means less matches were detected in the photograph. So you can sort of see already, looking at this, you can sort of see the type of things that are matched. So like my couch, all the wrinkles in the leather highlight quite well. The carpet, not much. You would think there'd be more there, but you know, maybe it's not quite in focus. So maybe it's maybe a bit blurry. The walls and the ceiling don't get much. So we have the light from the curtain, and there's a bit of a shadow or light on the wall. It's picked up some of that in between it, but the rest of the wall and the ceiling, you could basically get nothing. So any like white featureless surface, you're not going to generate any matches in that. So basically, you want something like that is very like rough or very a lot of like rough texture that can be identified in the imagery. So the next thing, so the type points is a pretty critical thing. The next thing is the error that's associated. So the next thing I look at is RMS reprojection error. So that's root mean square reprojection error. And I'll show you where that one is. So we go to show info, or we just, if you click on this, the chunk as well, go show info. We have a root mean square reprojection error of 0.31 for the raw photos. And that's about one pixel size error. And the maximum error doesn't really mean too much. That just means that there is some point somewhere. So we've got 21 pixels in error. So there's probably like one of these outliners out here, which would be causing us that maximum error. That's nothing really, not too bad. If you do have a lot of points out far away, that's not a good indication. That usually means you got some issue with your camera alignment. So from what I can see here, that they're lined pretty well from where I took them. The next one is the mean key point size. So that basically, again, like relates to the matches in the imagery. So if you have a point that is observed in, say, many photos. So for example, if I had a point that could be observed in all 10 photos, that would correspond to a smaller mean key point size. But if a point was only observed in, say, for example, 2 photos, it would have a higher mean key point size associated with it. So generally, you want a smaller, with all of these, RMS reprojection, max reprojection, and mean key point size, you want a smaller value. And again, like we can see that the smallest ones were in the video ones, but yeah, overall, very high ones were observed with the high resolution imagery. So the 48 megapixel images had a higher mean key point. So actually higher than everything. So they had a higher RMS reprojection error. They had higher max errors as well. So again, that comes down to how well the key points were identified in the imagery. So for some reason, the 48 megapixel imagery key points weren't identified well. The reason that the video might have been a high value as well is because it's an 8 megapixel image. So maybe the low resolution, the objects aren't quite as clear or sharp. So matching time is not a really big deal, but again, like with large data sets, time can take a long time to match these. So again, like the raw format, probably going to take a long time, and the larger, higher. Well, actually, no, it's not really corresponding to anything, but yeah. Oops. Memory, probably don't really need to worry about it too much, but again, larger data sets are going to consume more memory. Is everyone still there?
Yeah, he joined, I think, again, maybe.
Yeah.
Yeah, I'm back. My mobile internet sucks.
Okay. So the next step is to build the depth maps and the dense point cloud. So basically, again, in the workflow, you just follow it down. You'd say select dense cloud once you've got your sparse cloud. And again, the quality settings just correspond to the image scale that you use. And there's this filter that's here, so you can use a filter on the depth map. So I'll show you what a depth map is. And basically, it's just like darker shades of objects that are far away. And it calculates this just from the imagery, the overlapping imagery. So you observe these objects from multiple angles. You can work out its geometry. So you can sort of like add a filter to it, which basically like remove sort of like maybe like finer details. So sort of just blends it in a bit more. But yeah, I usually use an aggressive filter for a lot of things, because with the mobile phone, I find it's quite noisy. But generally, they recommend at least a mild filter. If you were maybe shooting something that had a lot of fine detail, so maybe some vegetation or something that you were able to photograph, you might disable the filter entirely. But generally, some form of filter is recommended. These ones here don't matter too much. I usually like to calculate point confidence, and we can use that as a way of filtering the point cloud later. This is only relates if you've done this, if you run this process before and you want to reuse the depth maps that you have created here. And the calculate point color, that doesn't really matter. It's just adds a bit of, just colors the points, but you can do that anyway. I usually just have that selected as standard. So if I just, the dense cloud that was generated, so what I mentioned before about calculating confidence. Yeah, so for example, you can clean up the point cloud a little bit. So the confidence is based on these depth maps. So it's how many, I think, overlapping depth maps. So again, it's like how many points are observed in more images. Oops. Depth sense cloud. So if we like remove them up maybe further, we start removing more points that are of low confidence values. You'll sort of start to see that their points are reducing. But I normally just remove the first level of confidence. So for example, going back to 0, you can sort of see that there's quite a bit of noise on the wall here. Probably not quite as apparent in this one, but other data sets can be quite noisy. So I usually just filter one of them. Go 2. Just sort of cleans it up a little bit. You don't necessarily have to generate a dense point cloud if you don't want it. This is just a product you can produce. So you can build a dense cloud or mesh. It doesn't really matter. These depth maps will be produced if you select to make a mesh or a point cloud. The only benefit in producing a dense point cloud is basically when you want to generate your mesh, you can choose to make it from these depth maps, or you can also use you can generate a mesh from the point cloud. I typically just use the depth maps. I find that dense cloud can be quite memory intensive. So, for example, you could use up 100 gigabytes of RAM quite easily from generating a mesh from a dense cloud. So the depth map is definitely a more less resource intense process. So again, it's a pretty simple process. You just follow this workflow through. So you align your photos, create a dense cloud if you want one. You might want one or you might not, but you can skip that process if you don't want one, and you can simply go to build mesh. So if you hadn't built a dense cloud, you only have depth maps or sparse cloud. So a sparse cloud you'd only ever use if you just wanted to generate something really quick. So your depth map. Arbitrary 3D, there's another option there. It's not here, but it will be like 2.5D. So that's just like basically a sort of more simplified terrain model. So you might use them for creating a digital terrain model or DSM or something like that. But generally arbitrary 3D for 3D objects. Arbitrary 3D is basically, generally like an object that could be closed. So like a round object or, something like this, it could be closed if we took enough imagery. Again, the quality size is the image resolution that you would process them at. So yeah, I did ultra high, but it depends on, on the data set. I typically limit the face count to 15 million. Again, it's just my hardware restraint. So
what does face count?
So this is like
Alexei?
how many triangles will produce. So for example, this 3D model here that was generated, it has 1,228,000 faces. With a larger model, it's just going to get, you're going to get more and more triangles. So if I was, for example, making a mesh with 1,000 photos, for example, you might get a mesh of 20 or 30 million triangles. And at that size, starts to become more intensive on your computer. So typically what happens is, if you just leave that to, for example, high, you'll get whatever amount that is generated. So it could be 1 million, 2 million, or whatever it is. But maybe if it's a really complicated mesh, you might get something in 50 million. I typically just limit it to 15 million. So what will happen is it will generate a mesh to say 40 million, for example, and then it will decimate that mesh down to 15 million triangles. So basically, yeah, if you had generated a mesh now, and you wanted to remove, so maybe you wanted to simplify it to 1 million. You go to mesh and you go to decimate mesh, and then you can just choose how many faces you want. And it basically just simplifies the model a bit. So yeah, this is the untextured model. So over here, so that's a textured model. I should have actually shown the shaded model first, because you have a bit more of an idea. Sorry.
You were showing something textured and non-textured, no?
Oh, sorry. Wilford did maybe. Okay, yeah. So yeah, okay. So this is the shaded model, and you can sort of see the imperfections in the mesh. So we can look at the manual. We can look at the raw one. Each model that was generated has like varying quality in it, but they're all quite similar.
Alex, which application you're using? Which software is this?
It's called Agisoft Metashape.
Huh?
It's called Agisoft. It's up here. You can see it in the top tab. Agisoft Metashape.
Just a minute. Let me see. It's Agisoft Metashape Professional. Okay.
Yeah.
Okay. Actually, my eyes are, I'm using like spikes, so I cannot read properly. That's why,
The Agisoft's actually quite affordable. I had the standard version. I bought a license for the standard version. It's $175 US. The Agisoft professional version, it costs I think about $2,500 or $3,000. But it's a one-off payment, so it's like a lifetime license. And there's other software you have to pay like a monthly or yearly subscription. Okay, so just looking at some of the worst meshes that were generated. So the mesh generated from the video, so the 8 megapixel images generated probably the worst mesh out of all of them. But generally, all of them are quite similar. So
I'm interested in the video, Alexei. So because you were showing us the one from images before, you had like 11 images, but a video is like 24 per second, right?
Yeah.
So
this
you would be adjusting every image.
Yeah. So this test, I did it purposely with 10 images just to be similar. But I also did one with 40 images down here. So that's again like with more overlap. So you can still.
So you select 40 images from the video or something.
Yeah. So I'll show you how that works. So if you had your empty workspace here, you just import your video. Do I have a video to show you? So you import your video, open it. If you know the frame, so I know for example, my graphics card, I got it set with 30 frames per second. Your phone will either be 30 or 60. So for example, you set for 30 frames, so you might say every 30, extract one. Or if you wanted more, you might say every 15. You can have an option, you can say large, medium, small. I don't really know what values they are, but I always just go custom and I just type in a number that I want. So yeah, maybe I do, every 30, just name it or something, give it a file name, where it is, put it somewhere. And then you can, just start from the beginning, or maybe there's a certain point you want to start from. So this is the video that I took for that particular, or one of them, either the 60 or the 30 frame ones. But that's the benefit of using video, is it's quick, and you can just extract what you need.
So you're using this tool to rip out some images from the video every interval.
I've been doing it, in this one. You can also do it in Blender if you have that software. You can split video into images with that software too. But yeah, this one's quite easy. It has, it's inbuilt, so just use this one. And you see here the position of each extracted frame in here. So this is a lot more dense, and you can sort of see that the overlap in this case hasn't really helped the mesh quality. In fact, it's probably just made it more noisy. So this is done with 10 photos, and then this 60 frame one with 40 photos. Maybe some things are more detailed, but generally it's just like more noisy, especially around the wall here. So these featureless surfaces. So yeah, I guess that's one of the things that I sort of want to test more, is like how good video is. And is there a point where maybe there's too much? Like sometimes less is more. So maybe like a better image, but less of them, or like a larger.
Maybe the video which was clicked, it's not capturing proper angles, or someone should be skilled enough to take this all stuff if you want to create the pictures from the video. Maybe.
I mean, there would be like when you're recording, there'd be maybe a bit of movement, and each image might not be quite in the focus as well. So that would probably have a factor. While when you're taking a still image, you're quite stationary and you're quite careful with how you take your photos. So this mesh was generated with the DLSR camera. Actually, different time of the day. This was actually this morning, while the others were taken yesterday. So different, probably not ideal comparison because the light is different. Again, it's still quite comparable as far as what can be generated with the phone. But yeah, still, I think they're quite comparable. Like the smartphone, what you can generate from a smartphone is quite quite similar. And yeah, the raw format again is probably like one of them, the better meshes, I think. But then the 48 megapixel one also turned out quite well too. But yeah, again, it's very objective.
On the other side of the little stool, the circular purple stool. If you look at that from the top, I want to know what happens at the back of it.
Oh, it would just be a blob, yeah. A blob, yeah.
There we go. That's an interesting angle to look at it.
Again, if you in the mesh settings, so when you build your mesh, you have this interpolation option, so enabled, disabled. So I always have it enabled, and that artifact there is a result of that being enabled. If you have that disabled, it will just be a hole, so you wouldn't have anything generated there.
Yeah.
If you have extrapolated, for example, maybe what would happen, it sort of try and fill this hole here, and maybe you would have this whole thing come around like some like it would maybe try and turn itself into a watertight object, so you might cover this whole thing if there's enough points. But there's no points here, so I don't think that would happen. But you know, maybe at least it might try and interpolate this area that's missing there. So maybe with with white walls, maybe that option might be good to have enabled if you wanted just to fill it with something rather than have these holes everywhere. That's something I didn't do though in this one. What was the next thing? Yeah, so yeah, that's the mesh. The only other indication of quality perhaps could be the number of faces that are generated when you build that mesh. So for example, the raw format, 1.2 million, basically 1.15 for the JPEG. We have just over 1 million for the auto mode 12 megapixel. With HDR, like a similar amount. So the 48 megapixel, we got more faces. We got 2.2 million. And then with the video, we got less. Yeah, like 700,000 for 30 frames, 60 frames. We got only 191,000 faces. So yeah, it's just because there's like less points, less matches, so less triangles or faces were generated. So basically, the next thing that basically completes this in the standard version is just to build the texture. So you have two options. I just use diffuse map. I've never done occlusion map. Just normally diffuse. So you can generate a texture from the 3D model. Generally, there's no benefit in doing that unless you already have a model generated that's got textures on it. You could use that as a source, but generally always images. This is like depending on what type of object that you might be wrapping the texture around. So maybe if it was like a bowl or something, you might choose spherical, but generally generic is the standard, for example. Again, I haven't really played too much around with these. I would use just on generic. So I've not really done something that has required any other setting.
What's an orthophoto?
Orthophoto. I am not too sure what that would be used for, but maybe that is. Yeah, I'm not sure actually what it does.
Like a technical term from remote sensing or something. It's like a.
Ortho is like a corrected photo, so it's like it's been corrected, like distortion and but it's I'm not sure what orthophoto has in as far as like mapping a texture. unless it's some sort of correction to it, perhaps, or maybe there's less. Maybe if it's been corrected, like how it would wrap around an object, perhaps. An adaptive orthophoto. Yeah, I'm not too sure what they're for. Something I'd have to research into. But yeah, orthophoto is like a corrected photo, opposed to just a normal image. But yeah, generic is what I normally do. Blending mode is like, so you're gonna have basically a series of overlapping photos. So it's like what image do you want to be used for that that texture? So you could say max intensity. So whatever image that was overlaid with the maybe the highest RGB intensity would be used. Or you could select average, which would do an average of the overlap photos. But generally, mosaic is the default. So basically, it will pick the photo. Actually, it will pick sections of all the photos, but it will pick a portion of it that is the correct angle. So that's also based on the camera angle. So if you're looking at that object at that maybe that perpendicular angle, that would use that portion of the image. But it's basically a blend of all the photos. The texture size, you can sort of make that whatever you want from up to 16,000, but I like to keep them a power of 2. So 8192 or 16,384 by 16,384. You can run into problems. So for example, if you exported this model into say Unreal Engine 4 and you had a texture size that wasn't a power of 2, it might give you an error. But generally you could say 8,000 by 8,000 or 16,000 by 16,000. It would still work, or 12,000 or 4,000 or whatever you want. But I typically just keep it for a standard, just the power of 2. And I think the 16,000 is basically the full image scale again. So this is like a half image.
So have you put any of these in Unreal Engine?
I have. I was gonna. Well, actually, I got one here. Actually, yeah. This was the inside of that. Inside that church. What's it? The Saints. What's the name of it? It was Saint Sophie. Yeah.
Crazy.
Yeah. So this is inside of it.
The National Museum, the Doha Qatar National Museum in Unreal Engine. That would be sick.
This model, actually, yeah, this is an outside model, a model inside the model. So this was generated just from
the model.
terrestrial photos. There's also a LiDAR data set, so this may have been generated with LiDAR and images. But yeah, you can put these models into Unreal and you can make like a virtual, virtual tour or something. The only thing that I haven't really got quite to work well.
BIM, Alexei. This is BIM, man. You need to have Unreal BIM.
Yeah, I haven't quite got the collisions to work yet on this, so you just run through everything. As well, the lighting in the game engine has a strange effect on the texture, so it's not quite the same. But yeah, something I will probably keep working on, I guess. Hang on, what was the camera? There we go. First person view. Can like explore a bit, stuff here. Pretty good. Like, if you could make some really high res meshes, you could, make your own game assets. That's something that I'm interested in doing too. So, any meshes that I create, can I make them like game ready? So you can explore. Oh, this is the outside. Go back inside.
That text on the wall is what I mean about using game engines for presentations. People, we should use Unreal for our presentations at work.
Yeah, but it need lot of like pictures and all, because this is if you talk about the video game, it will be a big thing, no?
Yeah.
It is probably a lot of work, but again, like this didn't take long. Like if you got the mesh, you basically just put it straight into Unreal. Again, this is This is the outside of it. If you have your mesh, you just basically import your mesh, and then you just drag it in there.
I want to put our whole pipeline network in Unreal. They've got CCTV surveys of a lot of the network, right?
Yeah, that is CCTV is only for the this purpose of pipe, no, quality of the pipe it's laid or not, and that's why they do the CCTV.
Yeah, but could you, because that's got nice, right? So you might be able to make a model from that.
I don't think so. The CCTV will be only it doesn't run all over though. They put something in the camera in the pipe and then it make a video of that.
Yeah, I guess as it goes down the pipe, it would get a series of photos, right?
Yeah, but I have heard that for water, no, they are having one bubble test. They put something, some ball kind of thing in the pipe just to see where the leakage is. That is called bubble leakage test. That they can use because the ball will flow all over the pipe and it will see the leakage.
Okay. There's a lot about CCTV I don't know about.
Yeah. It's a cool thing, man. So basically, you converted all the pictures to mesh and make this 3D modeling. Am I right?
Yeah, that's right. This is the one that I showed you earlier. So this is my house again. Actually, what I'll show you. So I'll just finish off what I was in Agisoft. So basically, yeah, the last step was to build the texture. Again, yeah, just select your setting. Most of these you can just leave them as they are standard. Just mainly it's the texture size is the main one. I usually like to go for the highest one, but again, that's going to make the file size really large if you go to full scale. Enable hole filling and ghost filling. So if I was to show you, so you notice all these holes here, it does actually fill that up. The texture, the building a texture does cover a lot of these, like these imperfections that you see in the model, all these dents and holes. The texture actually does cover quite a bit of that up. So if I put the texture back on, so it makes it look so much more cleaner. Get rid of the photos. Still a hole there though, but things like the clock has got, you can see pretty much.
It's clear now.
I mean that the blobs are still there, but yeah, you can see it's still there, but it's just covered up. The texture, you can't see it as much, but the imperfections are still there.
Yeah, it has created only the views which it can be seen from the pictures, only the elevation of those. Am I right?
Yeah.
You don't have elevation of that pillar, no? Beside this cooler AC. That's why you did not take that.
Yeah, that's just the shadow on the wall, but yeah, that's because the photo, yeah, that's basically the angle. Because this is the angle that we took the photo, so that's why it looks so clean. Because we're basically standing here when we took the photo, so it's basically just the photo plastered on top of that, so that's why it looks really good. Again, if you're looking down from an angle that we didn't take the photo, so we didn't take a photo from this angle, you can see like more messy.
Yeah, you're right.
So because we took the photo from that, we took the photo from this angle, it's looks really nice. But if we go 90 degrees, we didn't take any photos from this angle. You can see the texture doesn't look as nice. Like it's more like here, all these lines. And we definitely didn't take one from this angle.
So if you stood at the other end of that room and took photos of the other side, could you put them all in the same chunk and it would make a much more compelling model, or can you have photos from one angle or one viewpoint put into a chunk?
Yeah, so that's what I did here. So I did again, like I done this one room yesterday, and then this morning I went around and did every single room and outside, and then I made this one. So again, this is the room, the same room. I'll just get every software I use has different controls, so I have to like remember. Oops. Blender's shift and middle button to pan. So yeah, this is the room, and then I took images from like every direction. You can see
that looks really nice. The couch, the cushions.
Yeah, the cushions are, again, I probably didn't take a photo from like down here. And most of my photos were probably from about this angle looking down, or maybe from about here. But you can sort of see like I've taken photos from more angles than before.
Have you used this camera having 360-degree or from your mobile only?
Sorry, what was that question? Sorry?
Like the 360-degree angle picture, no, there is a camera which can take these all pictures. No, if you put somewhere here in the center.
Oh, yeah, so that's what I did with the Google Street View. I built the mesh from 360 images. And typically, yeah, they do work okay. Traditionally, though, you can get cameras that have like huge amount of distortion. So with those 360 cameras, you'll get it maybe on the floor. It'll be like really stretched on the floor and really stretched on the top on some cameras, or sometimes the top is okay, which in the Google image was fine, but the bottom is very distorted. So typically, you can just cut the bottom off. But yeah, you can use 360. You could use a combination. You could use 360 and you could use stills. You know, it just depends on. So for example, maybe in a room like this that's very tight, you might use some 360 to help stitch them together. But I only used what I had. So I have my mobile phone. Yeah, this is where I'm sitting at the moment. Here's a mesh of my computer making a mesh here.
I love it.
And then
so I'm guessing my crappy little Acer with a Core i7, it's not going to get very far.
Well, I've got a Ryzen 9 12 core. I have about 64 gigabytes of RAM, and I have a RX 5700 XT graphics card, so about 8 gigabytes video RAM. My CPU is also overclocked, so I got 4.3 gigahertz on all 12. And then it's pretty fast, but it still sometimes takes like a big model. I might have to leave my computer running all night.
Yeah, mine's not going to work.
And which application is this in where you open this mesh? This application is what software?
This one's called Blender.
Bentley.
Blender. Maybe I'll get a Blender. So it's a Blender is an open source software, so you can download it for free. Just download it for free. It's a pretty good actually 3D software. Open source. So I use Blender for you know, I use it for my 3D. So here you can see I've got faces. So on the top you can't see the roof, but if you were looking down, you can see it. So I just turned them off so you can see inside. But if I was to make this again, I would avoid filming the ceiling because I can't do the ceiling anyway because I don't have a drone or anything. So I'd probably avoid filming the ceiling and just having it open so I can have like a plan, like a house plan, and you can look into it.
So have you put all of these chunks together in one model, or did you put all the photos together in one chunk, and that is one chunk, that whole house?
This one chunk, yeah. I had done one before where for example, I might have done this tree as one chunk. I might have done this side as one chunk, and maybe this side is one chunk, and that side is one chunk, and the front is one chunk. But what you'd have to do is, in that chunk you have these photos, right, or this facade, but maybe in that chunk you also put some photos from this side and this side. So the chunks have some photos that are similar. So then when you do the alignment, it's going to have some key points that are similar as well. So then you can align them on either the point cloud or you could align them on the camera position. So if there's a camera position that is shared by both chunks, because you actually put the photos into that chunk, you can align them on the camera positions. So I had tried that before, and it worked.
So you mean to say the reference point should be in all pictures, like to join to edge match, no?
Yeah, you can try and join them. Like this one's done in one chunk, but it's not always successful. It just really depends on it. In this occasion, it was, but if you weren't able to, you would have to maybe do them in separate chunks. Yeah, it just really depends on the mesh that you're creating. So the way I got the inside and outside to line up, this is actually this is where I sort of went against the recommendation. I guess the photogrammetry recommendation is that that we use raw photos all the time. So raw. In this case, with this one, I went against it. I used the HDR. I had that enabled the whole time. Again, if you look it up like on Google about HDR and photogrammetry, it's recommended to not use HDR. And the reason I decided to use it is because if you were to stand by this window, you're standing inside, you're looking outside. If you have light coming in through the window, this window will be like really white or really bright, and everything inside will be really dark. And what the HDR does, it sort of balances automatically. So what is bright will make it darker, and what is dark will make it brighter. So it sort of takes like, your camera will take like multiple images, and it will sort of like take some of like a high contrast, and it will take some of the dark contrast, and it'll basically merge it together. So you get your darker shades, or the darker shadows a bit brighter, and then you get the lighter outside a bit darker. So what I was able to do is I stood by the window and I took a photo outside through the window, so I could see the ground from inside. I could see these bricks. I could see that that wine barrel. And then when I was outside, I took the photo here roughly, and then I maybe took another photo, maybe like here, and again maybe here, like overlapping everything. So you can see the features. You can see the features outside from the inside, while also maybe observing the fridge and you know, my thongs, or you know, all this stuff, and basically just stitching the model together based, you know, on the similarity. So inside here, I would take a photo here, photo here, photo here.
So you know from experience building models where to point the camera so that the software or the algorithm that photos will find common points of reference between them.
Yeah, it takes a bit of playing around. So why I've never successfully maybe got a mesh to merge like this. But yeah, I guess through experience, you just like playing around, you make so many, and then you sort of work out how to do it.
So did you do like a systematic pass? Like, did you walk in a certain way through the house, or did you just sort of willy-nilly, you know, brandish the camera left and right? You know what I mean? 'Cause you made that for the National Museum for me, where you wanted me to walk in straight lines and have the camera aligned in a certain way. Were you systematic with the house?
So first, I did this room first. So I did like as I explained to you before, where you know, you're looking at you might look at the wall, you might take a photo, take a photo, take a photo, take a photo here, and take another photo, and then you might just pan across.
Alex, I can't see your this system. I cannot see that.
You can't see it?
No.
It's working for me.
Yeah, maybe it's just dodgy internet. Yeah, I think the screen is still sharing.
So you mean you stepped sideways along the wall with the camera facing at the wall, basically, and when you got to the corner, you rotated with the camera pointing at the corner until you were effectively able to transfer onto the other wall.
Yeah. So basically, you want to focus on the center here because as you're rotating, you want to like have like this photo. You can see the clock. You can see all these stuff. You want that similarity that helps stitch the walls together. If you don't, so for example, you so say you take a photo of the wall, and then you take another photo, and then you're like maybe you rotate too aggressively. So you might take a photo and you might rotate again. There might not be enough similarity between those photos, and because when you're turning, you want to make that 90-degree turn, but each photo you take is going to be maybe not similar enough. So I find by like focusing on the corner and then doing a rotation around, you're getting heaps of photos, and you're observing all these objects from many different angles.
Okay, and that was all done with manual photographs. It wasn't done with video.
Yeah, manual. And then when you've done that, you just again, all the way around, and then you might take a photo, take a photo. You might also, so I've taken a photo of the wall, say maybe this far away. You might take another one, again, a bit further away and do the same thing. And you might also do one like right at the back here too. And again, like the same thing. So I did the whole wall around. If you happen to like backtrack over the same area that you have walked before, you might just take a different angle. So like hold the camera higher or lower, just so you're capturing something different. So you're capturing the same stuff, but just like a slightly different angle. And then this hallway, it's a bit hard to do sideways. So this one I actually just did, this one I did many passes. So I did it like just front on like that. And then I also did it slightly oblique again as well. So I did another one slightly oblique like that, just looking on an angle, and you can see into the bathroom there. And then I did the same as well on the other side, just slightly oblique, and the same coming back. So I guess the way I'll do it, I sort of did my room, and then I sort of do the whole length of the house just to get like a, sort of get the overview plan. So I did the wall, I did walk down here, and I did like a loop in this bedroom. And then again, like going back that way again. And then you might do another loop again, like you might, as you're walking down, you might go in a slight oblique angle. And then you might be taking photos of this kitchen while you're turning around. And you might focus on some feature here, or you might come back into the lounge room, and then you might focus on something, and then you come back. And maybe when you're coming back, I think I went down into this room, and again, just like walking through, just did like you can do like in a manual where you're standing against the wall, like a small room, you can do it. You don't necessarily need to do like every corner the way I said before, but in a small room, you could like walk in, you could have your back against the wall, and you could be taking photos pointing inwards, because it's small enough. You're basically gonna be close enough to the wall.
Yep. So sorry to cut in, Alexei. I'm just realizing it's getting on to 3 a.m. for you. So I guess from here, do you then upload it directly to Sketchfab, or?
Yep. Okay. So the good thing about this software is you can just upload it to Sketchfab. So you can upload data. You can upload straight to Sketchfab. Your account has an API key. You just put it in there and then upload it. If you want, if you want to upload to ArcGIS online, for example, you need to do another step. You need to build a tiled model.
Yeah.
And then you can export that.
So these vector tiles.
Yeah, you need tiles, and then you export the tiled model, and you could say as a scene layer package, and then just drop that into like,
Oh, so the scene layer package will contain the tiles.
Yeah.
Okay, and that gets uploaded to what did you say? ArcGIS Online.
Yeah. It'll have like levels of detail, so it might have like 10 levels of detail or something. And then the tile size again, if it's something at really high detail, you want a smallest tile size, but then you could go something bigger. It was the
levels of detail, like zoom levels, are they?
Sorry. It's its own level, so it's like if you zoom that far, it will be like a really like blobby simplified model, and then when you zoom in, it kind of like has like. We'll have your main model, then we'll have like 10 other models as well, just like in there.
Like cache when you're building your cache for imagery. Yeah. Okay.
It's done in Unreal Engine, so you build like basically you have like your proper model, and then you might have a simplified model. You might have 3 or 4 simplified models at different levels. So when you're like far away from the object, you don't necessarily need to see the details. So you can have the simplified model. It's nothing to do with BIM. I mean, BIM has like a very specific standard on what is level of detail. This is just like, better resolution and lower depending on how far you zoom out.